Hi students, this is Dr. K. Sarulan, Associate Professor, Department of Information Technology, R&D Engineering College. My dear students, now we are going to discuss about 8051 timers. In Intel 8051, there are two 16 timers registers. These registers are known as timer 0 and timer 1. The timer registers can be used in two modes. These modes are timer mode and counter mode. The only difference between these two modes is the source for incrementing the timer register. The timer mode In timer mode, the internal machine cycles are counted. So, these registers are incremented in each machine cycle. So, when the clock frequency is 12 MHz, then the timer register is incremented in each every millisecond. In this mode, it ignores the external timer input pin. Coming to the counter mode. In the counter mode, the external events are counted. In this mode, the timer register is incremented by each 1 to 0 transitions of external input pin. This type of transition is treated as events. The external input pins are sampled once in each machine cycle and to determine the 1 or 0 transitions. Another machine cycles will also be needed. When in this mode, at least two machine cycles are needed. That is, when the frequency is 12 MHz, then the maximum count frequencies will be 12 MHz divided by 24. That is equal to 500 kHz. So, for even counting, the time duration is 2 microseconds. There are four different modes of timer or counter. That is, mode 0, mode 2, mode 0, mode 1, mode 2 and mode 3. For both mode 0 to mode 2 or for both the timer counter, the mode 3 has a different meaning of each timer register. That is a register called T mode. These registers can be programmed to configure these timers or counters. The serial port is used for serial communications in mode 1 and mode 3. The timer 1 is used for generating the baud rate. So only timer 0 is available timer or counter operations. Coming to this T mode registers. In this mode 0, the mode 0 operations is the 8-bit timer or counter with 5-bit prescaler. So it is a 13-bit timer slash counter. It uses 5 bits of TL0 or TL1 and all of the 8 bits of TH0 or TH1. In this example, we'll see the timer 1 is selected. In this timer 1, every 32 seconds, event for counter operations or 32 machine cycles for timer operations. The TH1 register is incremented by 1 when the TH1 overflows from FFH to 00H. Then the TF1 of TCON registers will be high and it stops the timer slash counter. For an example, we can say for that TH1 is holding F0H and it is in timer mode. Then TF1 will be high after 10H into 32, that is equal to 512 machine cycles. Coming to the mode 1. In mode 1, the operation is the 16-bit timer or counter. In case every event of counter operations of machine cycle for timer operations, the TH0 to TL0 register pair will be incremented by 1. When the register pair overflows from FFH to 000H, then the TF0 of TCON registers will be high and it stops the timer slash counter. So, for an example, we can say that if TH0 to TL0 register pair is holding F0H and it is the timer mode, consider as imagine, then TF0 will be high after 10H, that is equal to 16 machine cycle. When the clock frequency is 12 MHz, then the following instructions code will be generated as interrupt 60 microseconds after timer 0 starts running here. Coming to the timer Z2. In timer Z2, operations is an 8-bit auto reload timer or counter. In the following diagram, we are using the mode 2 for timer 1. In this case, every event of counter for operations of mission cycle. For each timer operations, the TL1 registers will be incremented by 1 when the register pair overflows from FFH to 00H, and the TF1 of TCON registers will be high. Also, the TL1 will be reloaded when the content of TH1 and starts the operations again. Coming to the mode 3. The mode 3 is different for timer 0 and timer 1. When the timer 0 is working in mode 3, the TL0 will be used as a 8-bit timer counter. It will be controlled by the standard timer 0 control bits, that is T0 and INT0 bar inputs. The TH0 is used as an 8-bit timer but not as a counter. This is controlled by timer 1 and controlled bit TR1. When TH0 overflows from FFH to 00H, then TF1 is set to 1. In this diagram, we can see that timer 0 is in mode 3. When the timer 1 is working in mode 3, it's simply what it is going to do, it will hold the count but does not run. When the timer 0 is in mode 3, the timer 1 is configured in one of the mode, either mode 0, mode 1 or mode 2. In this case, timer 1 cannot enter the microcontroller. When the TF1 is used by TH timer, then the timer 1 uses a baud rate generator. The meaning of gate bit in timer 0 and timer 1 for mode 0 is as follows. It controls the running of 8-bit timer slash counter, that is TL0, as like mode 0, mode 1 or mode 2. Imagine this. The running of TH0 is controlled by TR1 bit 1D. So the gate bit in this mode for timer 0 has no any specific role. The mode 3 is present for applications requiring an extra 8-bit timer slash counter. In mode 3 of timer 0, while 8051 has 3 timers, one 8-bit timer by TH0, another 8-bit timer countered by TL0, and one 16-bit timer slash countered by timer 1. If the timer 0 is in mode 3 and timer 1 is working on either 0, 1 or 2, then the gun control of the timer 1 is activated. Then the gun control of the timer 1 is activated when the gate bit is low or INT1 is high. The run control is deactivated when it is high and TINT1 is low. Thank you, students.